I will set 20 voltage approximately and increase the duty cycle fully. I will give 90% duty cycle and the voltage is 18 volt. Input is 20 volt, output voltage is 18 volt at 90% duty cycle. If decrease the duty cycle means the DC voltage also decreased. Now 43% duty cycle, the output voltage is 13.89 voltage.
Okay guys, for this energy meter we are using Raspberry Pi as a core system. First I am gonna run the main code. Now if you see here there is a voltage and current and power measurement. Voltage is 244 and then current remains the same, that is 0.4 amps, and power is 99 watts. Now I am just gonna theft some current. So whenever I switch on this switches, that is if I switch on the two loads, so power is up to here, up to 200 here. It shows voltage and current and then power value in watts, and then it shows one message called power theft occurred. It is the functionality first. So after some minutes it's turned on the load again, then again it checked for power load, power gets turned off automatically.
This is the driver circuit, this is the control part, and this is the power control circuits. First of all, for increasing the intensity, we have to increase the voltage. Duty cycle will be increased with respect to the sensing value of IR. So whenever any detect passes through the IR, it will be detected and the duty cycle will be increased and the voltage will be increased, so the intensity will be increased. So that's the thing we are just doing. So whenever a car passes any other object, any object will passes, it will be detected and the intensity will be increased.
This is the main circuit of the multi-level inverter. This inverter 1, this is the inverter 2. These two inverters are connected in cascaded connection. The PWM output will shown in the output waveform. The black wire is the ground and the red wire is the positive. And I will show the output of multi-level inverter. This is the output of multi-level inverter. Main circuit of bi-level inverter. Driver transformer is used to given to the supply of driver board. Arduino controller is generate the PWM pulses. This is the power transformer to given to the power supply of main circuit. Connect the probe for these 2 points and shown the bi-level output for DSO. This project have two Arduino controllers. One controller is used to given to the PWM of this 15-level inverter, and another controller is used to control and monitor the temperature of all of the heat sinks. Power supply of this 15-level inverter. That MOSFET is control the speed of these two fans. The output of 15-level inverter is showing in DSO and also glowing the lamp. This is the 15 level output of this 15 level inverter. Heatsink temperature is monitoring in serial monitor.
This is the transformer, this is the driver circuit, and this is the grid controller, and this is the main circuit of wireless power transmission. Wireless power transmission through the coil. This is the primary, this is the secondary. The primary and secondary coil is very nearly, so only the voltage is higher, and if the distance is increased means the voltage is reduced.